Well, it is a new bit of research that's being published today. We've known about it for the last few months, but we haven't been able to talk about it until now.
What's this thing about?
This is a discovery about Alzheimer's disease, which I think at this point is something that affects basically every family.
Affected my family.
Yeah. And this is a discovery that is not a cure, but it's basically about looking at the brain, which is one of the most complicated things in the universe, I think, and poking at it in this super simple way and getting this bizarre result.
How bizarre?
It's pretty bizarre.
Hello.
Hello.
Hi, Molly.
Hi.
How are you?
All right, so last May I was talking to some folks over at the Brain Institute at MIT, and while I was on the phone with them, they started telling me about some research that hadn't been published yet, so it was all very hush-hush. It was pretty cool, though. We ended up deciding to sign a non-disclosure agreement, and it was based on the work of this woman, Li Tai.
Li Tai.
Tai, okay.
Yeah. I'm a professor and the director of the c0RoNa Institute for Learning and Memory at MIT.
Holy crap, you're the director. How do you have time to do all that?
I know, that's a good question.
She was like a badass is what she is.
But this is a piece of work I'm very proud of and very excited about.
Okay, cool. So let
me begin.
Okay.
So historically, people work on Alzheimer's really focus.
So I would say generally when you talk to researchers about Alzheimer's disease, they either focus on
individual genetic factors,
the genetics of the disease, so the genes that predispose you maybe to Alzheimer's,
or
the brain chemistry and how Alzheimer's affects the chemicals in the brain,
molecular pathological features.
But in my conversation with Li Wei, she was talking about something totally different.
We sort of look at it from a different angle.
Her work all centers around something called
the gamma frequency.
The gamma frequency?
Mm-hmm.
Gamma.
And what is gamma? I'm like, it feels like something from Battlestar Galactica. So I don't think it's that.
So the gamma, so-called gamma.
You could think of it as a particular beat in your brain.
A beat in the brain?
Yeah.
Which means what exactly?
Well, just to oversimplify one of the most complicated things in the known universe.
Okay, please do.
You've got your brain. It's full of neurons, which are a certain type of brain cell.
We have billions of neurons in the brain.
They have these long tentacles that are reaching out towards other neurons.
And for the brain to function, neurons have to communicate with each other to process information.
And the way they do that is they fire.
Yes.
An electrical signal will go through them and it'll like zap another neuron and it'll turn it on, and then it'll like an electrical signal will go through it and then it'll zap another neuron and it'll turn it on. But the cool thing is that when your brain is doing things like making you move or write a poem or think great thoughts, groups of neurons fire in sync all together on the same beat. And there's a bunch of different beats that happen in the brain. Some of them are slow, like 1 beat per second, and that's when you're sleeping. If you're beating around 10 beats per second, like maybe you're sitting next to a campfire in an Adirondack chair. Or on like the totally other end of the spectrum, like some neurons fire at 600 beats per second.
What are they doing?
That I have no idea.
And all this is going on in your head simultaneously?
Yeah. No, that's the cool thing, is that when all of these beats in your brain come together, that's when you're able to process the world and understand it as it exists as human beings. But getting back to our story, when your brain is doing something really tricky that requires super focused
attention, working memory, and so on,
like trying to find your way home from the subway station, or if you're in a new city, navigate around it, there's a certain beat that sort of rises above them.